pond should be filled with raw seawater. The only filtration should be at the inlet pipe to the pond, where a 300 to 400 micron mesh sock will remove fish egg and larvae. Prior to filling, dry pond beds should be sprinkled with dolomite or lime. Application rates are shown in the table. To promote phytoplankton blooms to support copepods, ponds need to be fertilised. Initial application rates and follow-up application rates are shown in the table. A mixture of inorganic and organic components are used to fertilise ponds. One inorganic component is monoammonium phosphate. Urea is another key component. Potassium nitrate is the other inorganic component used. Weigh the components according to the amounts recommended in the table. Various organic fertilisers can be used. At Bribie Island Research Centre, we use lucerne chaff and pollard. The organic fertilisers help to promote and maintain copepod blooms. With practice, weights of the organic components can be estimated volumetrically. Before jungle perch larvae have been stocked into a pond, paddle wheels can be used to help mix the applied fertiliser. Mixing water in the bucket with the fertiliser helps to aid its spread. If jungle perch larvae are in the pond, paddle wheels can no longer be used to mix fertiliser. Mixing of fertiliser is dependent on even scattering, aeration and airlifts. Within a few days of the initial fertilisation, phytoplankton and diatom blooms should begin. The aim is for these to support a copepod bloom. To supplement copepods that have entered in the raw seawater, cultured copepods can also be stocked into the pond. Allow the copepods to acclimate in 50% pond and 50% tank water before releasing them into the pond. To release the copepods, gently submerge and empty the bucket. Do not tip it from a height. Before stocking jungle perch larvae into a pond, it is important to monitor the density of copepods and copepod nuclei. It usually takes 3 or 4 weeks for the densities to reach sufficient levels. Collect a sample of pond water near an aeration point where the water is well mixed. Collect a 2 litre sample. Next, concentrate the 2 litre water sample using a 20 micron sieve. Concentrate the volume down to 200 millilitres. Then, use a pipette to take 6 1 milliliter subsamples from the concentrated pond sample. Before taking each subsample, gently blow down the pipette to mix the sample in the beaker. Examine the subsamples under a dissecting microscope. Count the number of copepod nauplii, copepodites and copepod adults in each subsample. Then calculate the average number per 1 ml subsample for each of the groups. Multiply the average number by 100 to estimate the total number of nauplii and copepods and copepodites in 1 litre of pond water. If the number of copepod nauplii exceeds 120 per litre, then it's safe to induce a spawn, then stock jungle perch embryos or yolk sac larvae. Alternatively, tank-reared larvae can be stocked at 7 days post-hatch. Larvae are not usually visible in a pond until 7 days post-hatch. At this stage, yellow pigment over the gut region makes them easy to spot. Larvae normally school near the surface and do this until metamorphosis. For this reason, paddle wheels should not be used. Aeration is acceptable. Early larvae prefer quiet water. As they grow, they move into the currents around the aeration systems. Between days 4 and 8 post-hatch, do not fertilise with lucerne or pollard. They may scum the surface water and inhibit swim bladder inflation. It's important to monitor the water quality of ponds. Salinity, oxygen, temperature, pH and secchi depth are all important. Adjustments can be made to the aeration, and if necessary, salt can be added to smaller ponds. If the secchi depth starts to exceed 1 metre, then a blue dye can be added to the pond. This non-toxic dye is available from aquaculture product suppliers. Follow the manufacturer's recommended application rates. The dye helps prevent Filamentous algae growth. Filamentous algae competes with phytoplankton and can inhibit copepod blooms. As jungle perch larvae grow, they begin to feed on adult copepods. If monitoring of plankton reveals a drop in adult copepod numbers below around 50 per litre, then supplementary feeding with Artemia may be necessary. By 3 weeks post-hatch, larvae are large enough to feed on Artemia nauplii. Half a tin of commercially available Artemia, hatched every second day, is sufficient to supply a 15 by 15 metre pond. Apply the Artemia near aeration points or adjacent to schools of jungle perch larvae. They will feed on it immediately and it should last them for at least 2 days.
Leave them down there, they start to come up and get excited for it. Wow, look at that.
Supplementary feeding with Artemia is generally only required for 1 or 2 weeks. Larvae can be weaned onto powdered feeds around the same time. Most commercial weaning diets in the 400 micron to 600 micron size range are suitable. As larvae grow and metamorphise into fry, larger diets of around 600 to 800 microns can be mixed in. Weaned fish soon learn to gather around auto-feeders. Metamorphosed fish tend to sit deeper, often around aeration. At this stage, water feeders can be supplemented by broadcast feeding. Mixing water through the feed prior to broadcasting helps it to sink down to where the fry are feeding. At this stage, fry may also be feeding on chironomid larvae. At less than 25 mm, jungle perch is sensitive to handling. Around 50 to 60 days post-hatch, most fry should be more than 25 mm in length. At this stage, they are robust to handling and can be drain harvested from ponds. Depending on the pond setup, the ponds can be drained via a screen dropboard system or through screen standpipes. When the ponds at Bribie Island Research Centre are low enough, screens can be removed to enable fry to enter a trap set in a pit. Traps are covered in a soft mesh, such as shade cloth, to minimise damage to the fry. Damming the drainage outlets in the pit with Besser blocks can raise the water level in the trap and reduce stress on the fish. Fish can then be dip netted and transferred to buckets attached to ropes. Buckets can be hauled up and transferred to a fish transporter with oxygenated seawater. If the blue dye was applied correctly to the pond, then the bottom of the pond should be relatively free of algae after the pond has been drained. Few, if any fish at all, should have stranded, but always check just in case. Harvested fingerlings can be transferred indoors for rearing in tanks.